Okay, well, problem 4, it rests completely, it depends completely on a simple formula. It's a simple formula like this: the sine of any angle. Well, any angle, let's say in the first quadrant. We're going to stay with these ones we've been dealing with that are all in the first quadrant. But the sine of an angle, say theta, we'll call it theta, is always equal to the cosine of 90 minus that angle. 90 minus this. It's a simple idea, but it somehow becomes quite complicated dealing with problem 4, or it seems to anyway. Now, we can apply that to an example. Take the 30 degrees that I've been using a lot lately because it's got some nice numbers. If this is 30 degrees, what this formula tells us is that the sine of this angle, and remember the sine was the opposite over the hypotenuse, and it's always going to, the sine of 30 is always going to be in this ratio. I used decimals. Now, so we know the sine of theta, the sine of 30 degrees. I'll put this down here. Now, what's 90 minus, wait, let's put it like this. 90 minus 30, which in other words we're talking about the cosine of 60 degrees. I'll keep writing this each time so it's quite clear what I'm saying. The sine of 30 equals the cosine of 60. Since, 60 is 90 minus 30. Let's make a picture of that. 60, I would guess, would be something like this. This angle is something like 60. Now, you see, the cosine of that is the adjacent leg over the hypotenuse. And in this case, the adjacent leg is 0.5 and the hypotenuse is 1. So, the sine of theta is equal to the cosine of 60. And if you don't believe me on that, wait, where's my calculator? You can just check it like this. Like here's my calculator. I'll ask for the sine of 30 is, well, I put it in wrong. Wait a minute. The sine of 30 is 0.5. The cosine of 60 is 0.5. That was just to verify what I just worked out on the drawing. Now, let's take one other example before we work problem 4. Let's take another angle. Like, what if we had an angle like 10 degrees, kind of a little one. By the way, I'll save that point for later. But now, 10 degrees, the sine of 10 degrees, which as we know is this side of the triangle over the hypotenuse, should be, and we'll check this with a calculator, equal to the cosine of 90 minus 10. In other words, the sine of 10 should be equal to the cosine of 80. And what's 80 degrees? 80 degrees is a real tall angle. It goes way up here like that. Maybe even more. These pictures are just approximations. In my other video that I made for problem 8. I don't like now the way I drew cosine, the angle 68.5 or whatever it was. I didn't make it go up high enough. But that was in the other video. Now in this one, I'm just trying to make it look something like, if that's 80 degrees. So let's just look this up in the calculator and see what they tell us. The sine of 10 degrees is 0.173648. I'll write it down here. 0.173648. Now, let's check if that's the same as the cosine of 80. The cosine of 80 is, well, not surprisingly, it's the same number, 0.1. Move that, 0.17. So anyway, that's the idea of this, behind this whole problem here. Problem number 4. Now, let's work the actual problem, because we're going to just use the same formula. Now, the question that they gave us starts out like this. I'll put this up at the top. This was number 4. Or let's just start with it down here, okay. Now, number 4, they give us the sine of 2 beta plus 5 equals the cosine of 3 beta minus 25. What they're asking is to find a value for beta that will make this equation work, that will make this true. Now, let's use that formula that we were using previously in this same video. This is an angle. In my previous video I was using like theta. And this is the theta. In other words, the sine of whatever is inside the parentheses is going to be the cosine of 90 minus this whole thing here. 90 minus 2 beta plus 5. Let me just repeat that quickly. In other words, if previously in this video, if this is theta here inside the parentheses, and over here, this is 90 minus theta. So, or 90 minus the angle. Now, at this point, we can, let's write this like, what did I do next now? Oh, sorry. Now, you notice this. This is equal to that. And this is also equal to that. They're both equal to the same thing. Now, if this and this are both equal to the same thing, then this must be equal to that. You know what I mean? This expression here, both of these expressions are equal to what's on the left-hand side. Therefore, we can say this. I can write it horizontally. The cosine of 3 beta minus 25 is equal to the cosine of 90 minus 2 beta plus 5, because this is equal to that. Now, we've got a cosine. We don't really need the cosine in this equation, because you see, if the cosine of x is equal to the cosine of y, in other words, I'm calling this is x and this is y inside the parentheses, then x must be equal to y. That is to say, this inside the parenthesis is equal to this. So let's remove the cosine from the equation, the COS, and just write 3 beta minus 25 is equal to 90 minus 2 beta plus 5. Now, oh wait, I hope you can read that okay. I was looking at my page, I wasn't. So now we have this is equal to that. If you could see my page all the time, what's inside the parenthesis is equal to what's inside the parenthesis over here. Now we've run out of room on this page, so I'm going to go to one more page here. Give them another. And just to remind you where we stopped here, I'll rewrite what we ended up with on the other. 3 beta minus 25 equals 90 minus 2 beta plus 5. And remember the original question was this. I'll put that up at the top. Number 4 said the sine of 2 beta plus 5. I'm writing fast now. I'm writing too fast. The sine of 2 beta plus 5 is equal to the cosine of 3 beta minus 25. That was our original problem. Now, let's use a little bit of algebra on this. This is just a simple algebra equation. On the right-hand side, we need to distribute. This is like a -1 times each of these. So, I mean, I'll rewrite this as 90 minus 2 beta minus 5. Don't forget, minus applies to both of these things. And I'll bring this down. And now let's add 2 beta to both sides. We get 5 beta. I'll do this a long way. I could add the 25 now, but okay, let's do this. 90 minus 5, since the 2 beta has gone over there. 90 minus 5 is 85. Now we'll add 25 to both sides, and we get 110. I've done this already before I made the video, so I kind of know these numbers a little bit. Now, here we have, let's divide by 5 on both sides, and that's going to give us our beta. It's the same beta that I figured out a few days ago over in the tutoring lab, but this is the right answer, which I had the other day, but what I did not do the other day was, we want to check and make sure that's really correct. The way to check it is this. Take this beta equals 22 and plug it into this equation up here, and it should work. In other words, it should give us the left-hand side is equal to the right-hand side. So I'm going to do that right now. Taking that beta and plugging it into the equation up here, the sine of 2 times 22 plus 5 should equal the cosine. Do we have room here? Should equal the cosine of 3 times 22 minus 25. That is to say, the sine of 44 plus 5 equals the cosine of 66 minus 25. That is the sine of 49 degrees. I was writing in degrees. The sine of 49 degrees should equal the cosine of 41 degrees. And we could look up those numbers and see what they are just to check that. The sine sine of 49 is 0.7547. Let's put that like this. Now, let's check out the cosine of 41. The cosine of 41, if you can see it on the calculator here, it's a little bit hard. Now the cosine of 41 is, well, of course it's the same, 0.75, just round it off like that. Now the point is, I want to make sure you can see everything here. That means, you know, this value of beta, 22, is correct, because I plugged it into the original equation that they gave us, and it came up with the things even. Now the last thing I'll do with this then, let's make a picture. What do you think that would look like? In other words, what are we trying to show here? Here, let's say a 45-degree angle is something, you know, halfway. 45 degrees is splits this up into 45 plus 45 equals 90. So you see, our answer, I can make this a little bit better here. Our answer is talking about the sine of 49 degrees and the cosine of 41 degrees, and we're saying those are equal. So, you know, 49 degrees is a little bit bigger than 45 degrees. So I think 49 degrees would be something like this. Here's my picture of 49 degrees. Now 41, which is what the other right-hand side thing, is a little bit less than 45. So it might go up about like that. And let's say this is 41 degrees. The solution that we came up to with this problem, you see, is saying that the sine of 49, which could be the opposite over the, I'm calling the, as I often do today, the radius or the hypotenuse is 1. The opposite side is 0.7547. And then with the 41 degree angle, we want to do the cosine, so we're talking about the adjacent side over the hypotenuse. And those triangles, or those angles that are the solution to our problem, are going to be something like this, 49 degrees and 41 degrees. And they use the value of beta that we calculated.